tangent slopes, let's look here. The tangent slope here would be what? Good, I picked blue and then it didn't list me. It would be increasing or what? Positive, correct? Even here it would still be positive. What happens at the maximum?
Stops. Comes around.
It's horizontal. And what's the slope of a horizontal line? 0. So when it's increasing, I have positive tangent slopes, right? So this is when tangent slopes are greater than 0, correct? Then at a max or min, I have tangent slopes what? The tangent slopes equal what? 7? When you have a horizontal line, guys, hey, can you guys stop sidetracking? What does the tangent slope equal? 0. Then what about tangent slopes as I'm decreasing? What are they? Negative, less than 0. So here, the tangent slopes are less than 0. What happens here at this minimum? You get a tangent slope of what? Equal to 0. And then what happens as I'm increasing again? What are my tangent slopes?
Positive.
Positive. So, if we base our graphs completely off of tangent slopes, it'll give us information about the graph. So, wherever the tangent slope meaning first derivative, correct? Wherever the tangent slope equals 0, what do we get? Max and min. We can also get points of inflection as well if it increases, decreases together, which we'll talk about. Is a possibility. Okay, when the tangent slope is greater than 0, what happens? Rising up, which means the graph is doing what? Increasing. And then where the tangent slope is less than 0, what's happening? Decreasing. So wherever the tangent slope equals 0, this is called the critical numbers. Of the first derivative. Basically the x-intercepts of the first derivative, right? In 30-1, I could never ask you for the maximum minimums algebraically. In 30-2, we could, because you only had quadratics. You could complete the square, get it into vertex form, and then you could give me the y, which was the maximum, correct? But degree 3, 4, and 5, which was in math 30-1, if we asked for maxes and mins, we couldn't ask for it algebraically. You guys had to be able to get it with your calculator. Well, not anymore. Because wherever the tangent slope equals 0 is where your max and mins and points of inflection will occur. So we'll be able to do it without our calculator. So, let's look at the first one. I'm going to do some polynomials first so I don't lose people. Okay. Example 1. Determine. E-Ray, can you close the door for me, please? Thank you. Determine the critical numbers of the first derivative. So all we're doing right now is just finding where that tangent slope equals 0. So A, f of x equals x cubed minus 3x squared. Can everyone type that into their y equals with their calculator? So, when you type that into your calculator, I see a max and a min. Does everyone else see that? We are going to get the critical numbers of the first derivative. That's where the max, the x values where the maxes and mins occur. So if I see a max and a min, I'm suspecting that there will be two critical numbers, correct? One of them being 0, because the maximum is at 0, 0. And then one of them being wherever the heck that minimum is, which looks like it could be 2, possibly. We're just finding the critical numbers. We're not finding out if they're maxes or mins yet. So the critical number, we take f prime of x, and we find that first. So how do we do the derivative of x cubed minus 3x squared? What are we going to get? 3x squared minus 6x. And the critical numbers are where the tangent slope is equal to what? 0. So we do 0 equals 3x squared minus 6x. How can I solve this? What can I take out of here? 3 and an x. And what am I left with? X minus 2. Then what do? Set them equal to 0. 3x equals 0. Divide by 3. X equals 0. And this one, x minus 2 equals 0. X equals 2. On our calculator, where are mins and max at? 0 and 2, correct? So being able to find that first derivative and being able to find the x-intercepts of the first derivative, we will find where the max and mins are. We're just finding critical numbers right now. We're not finding out if they're maxes and mins. That's a whole other ball game. So we have to find out where it's increasing and decreasing. But for right now, we're literally just finding the critical numbers. So x equals 0 and x equals 2. Okay, I'm going to give you another one. B. We do a few polynomials, then we're going to move to other ones that aren't as easy to find. X cubed minus 6x, sorry, f of x equals x cubed minus 6x. Double checking by typing them into your calculator, finding where the max and mins are. And then C, f of x equals x to the 4th minus 2x squared plus 1. So try those two out. This one, f prime of x equals 3x squared minus 6. And then we get 0 equals, take a 3 out. We're left with x squared minus 2. 3 does nothing. X squared minus 2 equals 0. X squared equals 2. X equals plus or minus root 2. Done. And then C, f prime of x equals 4x cubed minus 4x. And then 0 equals, take a 4x out, and I'm left with x squared minus 1, which I can just solve by itself, or I could say, hey, it's a difference of squares and split it up. X plus 1, x minus 1. So I get x equals 0, and then plus or minus 1. Great if you don't have to set each one of those equals to 0 if you did 30-1, you can just pop down to the answers. Yeah? Okay, that's polynomials. What happens if I give you something that's not a polynomial? So B, Jill can use power rule this one. So I'll have f of x equals x to the 2/3. E, f of x equals 2 root x. F of x equals x plus sine x from 0 to pi. So x to the 2/3, please. X to the power of 2/3. So it looks like maybe 0 might be a place where we have something going on, right? In the moment, looks like. So we're going to do f prime of x equals 2/3 x to the what? Negative 1/3. And then our critical numbers are where the first derivative equals 0. So we're going to raise this to the -3/1. 0 to anything. What am I doing? Anyone? Bueller? Don't even. I'm going to go 0. Oh boy. He even took that away. I have to get rid of the 2/3 first. Reverse bed mass, Lepp. Reverse bed mass. Some people's children. Okay. And then raise this to the power of -3. So x equals 0 is what we were hoping for. Okay, let's go to our y equals and clear that out. Let's put in the other one, 2 root x. So this looks like it might be a 0 thing too. So we go f of x equals 2x to the half. Remember, the first thing you always want to do is make radicals be rational exponents, right? Which is why in grade 10 it's taught. F prime of x equals 1/2 times 2, x to the -1/2. 1/2 times 2 cancels, so f prime of x equals x to the -1/2. And then 0 equals x to the -1/2. And we raise to the power of -2. So once again, x equals 0. Okay, then we have a trig one. So let's type this one in. Clear it out. We're going to be x plus sine x. What do we have to make sure we're in? Radian mode. And our window, x needs to be 0 and our x max needs to be pi, correct? Okay. So we have f prime of x equals 1. What's the derivative of sine? Cos x. And so we have 0 equals 1 plus cos x. And then we have cos x equals -1. Where does that happen at? Where does cos x equal -1? Pi? Some people will say, well, what about 0? Remember, 0 isn't a minimum. It keeps going and it goes down to a minimum. Because where does cos x equal 0? Where does cos x equal -1? At pi. Okay. Now what if we are given ones that need not power rule? You know what I'm going to do? So let's type this first one in. Go. Y equals x square root 1 minus x squared. Typing it in. Press graph. Looks like it's got two little max and mins that occur between 0 and 1 and 0 and -1. Correct? Okay, so let's try it out. So we have f, we have g. F is x, so f prime is 1. G is 1 minus x squared to the half. So G prime is 1/2, 1 minus x squared to the negative a half, times negative 2x. And then this negative 2x and half can join, correct? The negative half and the 2 can join. So you get G prime equals negative x, 1 minus x squared to the negative a half. All right. Side note. So f prime of x equals G f prime plus f and then G prime. Oops. Negative x and then 1 minus x squared to the negative a half. This is where I told you if you can't take the GCFs out, the next unit is going to be impossible, correct? Because we're forgetting our critical numbers. This very moment in time. So what can we take out of these two? 1 minus x squared to the negative a half. And when I do that, out of a half, take out a negative a half, I get 1. So I get 1 minus x squared. And then plus negative x squared. These two together. And then that's gone. So I get 1 minus x squared to the negative a half. And then here I get negative 2x squared plus 1. All right, let's see what we get. So these have to equal 0. We agree? So I've done nothing different than what we've done before, correct? It's the same work we've done this whole time when we had to do product rule with a radical. So now I have 1 minus x squared to the negative a half equals 0. How do I get rid of negative a half? I raise to the negative 2, which does nothing to a 0. So I get 1 minus x squared equals 0. Then 1 equals x squared. And then x equals what? Plus or minus 1. Because the graph ends at 1 and negative 1, right? Because of our domain. And then here, we have negative 2x squared plus 1 equals 0. Negative 2x squared equals negative 1. X squared equals a half. And then we take the square root, and we get plus or minus in front. Now remember, you were taught in grade 10 that you can split a radical up if one of them is a perfect square. So that you don't have a radical over the whole thing. So you could go x equals plus or minus root 1, which is 1 over root 2. And welcome to calculus, because you don't need to rationalize. So these are the critical numbers. These are the endpoints. And how I know they're endpoints is, remember in 30-1 you were taught how to find the domain. So you did adding, subtracting, multiplying, and dividing different functions in that unit. If you're in my classes, we did it last, very last. I think most classes did it very last. I think you guys might have done it like first or something.
Sorry.
Adding, subtracting, and multiplying and dividing different functions together. So what we learned when we did that, though, is that when we added, subtracted, and multiplied functions, the domain is where both of them exist. Remember that? So, side note, if I gave you this, so if I gave you f of x equals x times x squared plus 6, I could just say, what's the domain of y equals x? Infinite, correct? What's the domain of a quadratic? Infinite, yeah? So where do they both exist? Infinite, so it would be everywhere. If I gave you this in 30-1, root x, and then x squared plus 6, we don't need a calculator. This one here, what's our domain?
Infinite.
Infinite. What's the domain to this one?
0 and above.
And equal to 0, correct? So the domain of this whole function is where both overlap. So where do they both overlap? There. Right? That's what we learned with adding, subtracting, and multiplying. Dividing was the same thing. You just had to watch yourself because if there's non-permissible values, those could come into account. Okay? So if I look at the one that we had going on here, this one has 1 minus x squared under the square root. 1 minus x squared under the square root and x, which comes from grade 11. And you guys don't get this in grade 11, so pay attention. What is the domain of y equals x? Negative infinity, positive infinity. That's not my limiting factor. This one, however, is. So this is actually a graph that is concave down with a maximum at 1. So it looks like this. And we did this actually in 30-1 as well. Remember when you took the square root of a function, what happened? So this is 1 minus x squared. Y equals 1 minus x squared. When you take the square root of it, remember your x's and y's stayed the same for 0 and 1. Remember that? This stayed here. This went a little higher, this went a little higher, and the 1 would drop to root 1, and you got a graph that looks like this. Remember that? So the domain of this function is actually from -1 to 1. So where's the domain of the combined function at then? -1 to 1. Do we agree? So that's why we're taught adding, subtracting, and multiplying and dividing functions in 30-1 in pre-calculus for calculus for this moment. So I know that the restricted domain on this function is between -1 and 1. So if it comes up as a critical number, but the number is one of the restricted domain numbers, it's just an endpoint. It's not a max or a min. Okay? Let's look at this one. This one's domain is a quadratic, so it's negative infinity, positive infinity. What's this one's domain?
0 and above. Right.
This has to be greater than or equal to 0, yes? So 2 minus x.
Above 0.
So 2 is greater than or equal to x. So what does x have to be?
Less.
Less than or equal to 2. So it would be from negative infinity to 2, right? So the restricted domain is this one, so that's the domain of both of them. Do we agree? Okay. So f is x squared. F prime is 2x. G is 2 minus x to the half. G prime is 1/2. 2 minus x to the negative a half times -1. So it's -1/2. 2 minus x to the negative a half. So f prime of x equals g times f prime minus, or sorry, plus f times g prime. So remember this moment, what can we take out of these two? Guys, what can we take out of those two?
2 minus x and negative
2 minus x to the negative a half. And what else did I want you to take out?
an x.
You could take an x out, sure.
And the negative 1/2.
And -1/2 or just 1/2. It doesn't have to be this, like the sign. You just have to take that half out, right? Okay, let's see what's left over. So I take a -1/2 out of a half, I get 2 minus x. I took the x out. When I take a half out of 2, what does it become? 4. Minus x, and then that's gone. So I'm left with x on the top, 2 minus x to the half on the bottom, with a 2 in front, because that half drops. And then I get 8 minus 4x minus x, which is 8 minus 5x. Do we agree? Okay. So we're gonna get x equals 0. We're gonna get 8 minus 5x equals 0. 8 equals 5x. X equals 8 over 5. And then the 2 does nothing. And then 2 minus x to the half equals 0. Raised to the power of 2 changes nothing. 2 minus x equals 0. 2 equals x. This is an endpoint though, correct? Because we have that restricted domain. This is an endpoint. This is a critical number, where maximum min are. All right.